Good morning, everyone. So this is the lecture number 13 of engineering mechanics. So we are meeting today after 10 days due to your admission process. We could not conduct the lectures in the last week. So during the last lecture, we were discussing about the general force system. Okay. And we solved some problems on the general force system. So I will repeat that problem in the today's session because you must have forgotten some concepts from the general force system, then how to find out the resultant of the general force system. Okay. So this was the last problem that we were discussing. So this is the problem of the general force system on the dam, and we have to find out the resultant, and we have to locate that resultant with respect to given point. Okay. So we will just repeat that problem. So those who are attending this lecture first time, they can note it down. So the problem statement is a dam is subjected to three forces. One is 50 kilonewton on the upstream face AB. Then second force is a 30 kilonewton on the downstream inclined face. And its own weight of 120 kilonewton. As shown in figure. Determine the single force and locate its point of intersection. With the base AD assuming all forces to lie in a single plane. So this is a coplanar force system. Okay, so this is the given statement, and this is the actual figure. So this is the hydro dam, and on the hydro dam, three forces are acting. One force is on the upstream side, second is on the downstream side, and third is the self weight of the dam. Okay. So what is meaning of upstream and the downstream? So here you can see this is the backwater. Okay. So this backwater, it will create a force on this wall. So this is called as the upstream side. This is the downstream side. Okay. So because of this water on the downstream side, there will be some force which will act in the perpendicular direction to this inclined plane or inclined wall. Okay. And due to cement concrete and other material in this wall, there will be self weight. So this is the self weight. So we can say this is the W. So these are the three forces, one on the downstream side, one on the upstream side, and one in the downward direction, that is the self weight. So we have to find out the single force. So here you can see, determine the single force. So meaning of this single force is we have to convert these three forces into equivalent force, that is called as a resultant. So question is, we have to find out the resultant value, that is the R. We have to locate that resultant on the base AD. Okay, so this is actually base for this dam. So on this base, we have to find out one point where resultant will intersect. Okay, so we have to locate the resultant. So this is the second question. So I hope this question is clear. So this is general system. Now we have to draw the actual system. So this is the wall of that dam. On the upstream side, there is one force exactly in the horizontal direction. So this force is 50 kilonewton. Then in the downstream side, there is one force perpendicular to this inclined surface, and this is 30 kilonewton. Now distance of this force with respect to this corner point. So let us take this point D. This is point A. This is point B, and this is the point C. So this distance, this is 1.5 meter. Then distance of 50 kilonewton with respect to point A, this is equal to 2 meter. Then this is 4 meter. This is 2.5 meter. And the self weight, it is acting from this point, that is the center of gravity. So we can take this point as a G, and distance with respect to upstream side, that is AB, it is equal to 2 meter. And this self weight is equal to 120 kilonewton. Okay, so these are the given forces, and the distance AD, that is a base, it is equal to 5 meter. So this is the given force diagram that represent a general force system. So right now we are solving this problem on the general force system. So what is meaning of general force system? So I hope everyone knows what is meaning of general force system. So general force system means what? Forces are acting at different locations and in the different directions. Okay, so this is called as general force system. So question is, we have to find out the R value. So to find out R value, What are our steps? First step is resolve the forces. In X and Y direction. Okay. Then second step, write down summation fx and summation fy. Third is use the formula R is equal to square root summation fx square plus summation fy square. Then find out the angle for the resultant, that is a theta, by using formula tan inverse summation fy divided by summation fx. So this angle, it is with respect to x-axis. Once we get r and theta, next step is find the quadrant. So this quadrant, it depends on the summation fx and summation fy. We have to just observe the direction for summation fx and summation fy, and depending on that, we have to find out the quadrant. Okay. And then to locate the resultant, so second question is we have to locate the resultant r. That means we have to find out the perpendicular distance d with respect to a given point. So to locate the resultant r, we have to use the Varignan's theorem. So by using Varignan's theorem, we will get a perpendicular distance. Generally, we take this distance as a distance d. Okay. And then by using trigonometry, we can find out the intersection of that resultant on the base AD. So somewhere, if this is the point of intersection, okay, first we will find out the perpendicular distance by using Varignan's theorem, and then by using a trigonometry, we can find out the intersection on the base AD. Okay, so this is the complete procedure to solve this problem. So we will see this one by one. So first step is we have to resolve the forces. So we will only resolve those forces which are acting inclined to x and y axis. Okay. So right now in this figure, nowhere x and y axis is given. Okay. So we have to visualize that x and y axis. So just I will draw that axis as a reference. So vertical will be the y axis and this will be the x axis. So this is just for the reference, so you can understand the x direction and the y direction. So you can assume this vertical line AB as a y axis and this horizontal line AD as a x axis. So if you observe this figure, then this 50 kilonewton, it is parallel to x axis. Okay, so there is no need to resolve the 50 kilonewton. This 120 kilonewton, it is exactly acting in the y direction, that is a negative y direction. Okay, so there is no need to resolve the 120 kilonewton. But if you observe this 30 kilonewton, which is acting inclined to x axis or the y axis, so we have to resolve this force. So when you resolve this force exactly at this point. Okay, so let's take this point as a point M. Okay, so at the point M, just construct one horizontal line as a reference. Okay, construct vertical line. So these two lines, they will represent x and y component. Okay, so this is the direction. Okay, so we have to take the direction for the x component like this. So this will be the x component and this will be the y component, and this is the direction for the y component. Okay, but for 30 kilonewton, this angle is not available. with respect to either x-axis or the y-axis. So this 90-degree angle, so this angle, it is not with respect to x-axis or y-axis. It is with respect to this inclined line CD. Okay. So first we have to find out the angle of this 30 kilonewton with respect to x-axis or y-axis. So just extend this line, that is called as line of action. So you can see here. Okay. And if you find out this angle, then that will be the angle with respect to x-axis. So this angle will be same for the x component. Okay. So just observe the given dimensions. So to find out this angle, just we will assume this angle as a theta. Okay. We know this angle. This is perpendicular, that is a 90-degree. So can we find out this angle from the given dimensions for this complete dam? Okay, we can find out this angle. So let us assume this angle as a phi. Okay, so this phi angle, it is nothing but, let us take this point as a point P. Okay, so this will be tan inverse Cp divided by the PD. Okay, so PD distance, this is equal to 5 minus 2.5. So this is equal to 2.5. And this PC distance, it is equal to 4 plus 2, that is 6. Okay, so I will write tan phi, it is equal to, just I will draw the figure. So this angle is phi, this angle is C, this angle is P, and this is the D. Okay, so this is a right angle triangle CPD. So in this right angle triangle CP, this side is equal to 6 meter. Then PD is equal to 2.5. So you can use the trigonometry. Okay, tan phi is equal to opposite side divided by the adjacent side. So you can get the value of phi. This is equal to tan inverse 6 divided by 2.5. Okay, so if you have the calculator, then you can solve this. So can you tell me what is the answer for phi? Yes, you can check this answer. It is 67.38 degree. So have you got the same answer for phi? So now observe this triangle, this small triangle. Okay, so in this triangle, this is 90 degree. This is phi, that is 67.38. So we are interested in theta angle. Okay, so theta is equal to 180 minus 90 minus 67.38. So the answer is 22.62 degree. So this angle theta is nothing but this angle. So this is equal to 22.62. So now you can resolve this forces 30 kilonewton. So the x component, it is the adjacent component. So this will be 30, that is the magnitude for the force. And adjacent means it is a cos 22.62. So this is the x component. Now y component, it is the opposite component to this angle 22.62. So this value will be 30 sine 22.62. Okay. So now we have resolved the 30 kilonewton into X component and the Y component. Okay. So now next step is, first is the resolution. Okay. Second is we have to write summation Fx and summation Fy. So for the summation Fx, we have to just add all X component, and for summation Fy, we have to add the all Y components. So just observe the forces acting in the X direction. So one is 50 kilonewton acting in the positive X direction. Okay. There is no component of this force 120. So next force in the X direction is 30 cos 22.62. But its direction, it is in the negative X direction. Okay. So write summation Fx. This is plus 50. Then this 30 cos 22.62, it is in the negative X direction. So it is minus 30 cos 22.62. Okay. So these are only two forces in the X direction. So we will get the summation Fx value. So this is equal to 22.30. Unit is kilonewton. And as the answer is positive for summation Fx, that means your summation Fx value will act in the positive X direction. Similarly, write down summation Fy. So for the summation Fy, consider the Y forces. So one is 120, but this 120, it is acting in the negative Y direction. So it is minus 120. Next force is 30 sine 22.62. Again, it is acting in the negative Y direction. So it is minus 30 sine 22.62. So these are only two forces in the Y direction. So we will get the value. So this is minus 131.53. Unit is kilonewton. And this minus means what? It is negative Y direction. So we can write this value as a 131.53 kilonewton, and direction is negative Y direction. So this is the representation. Okay. So now by observing this summation Fx and summation Fy, we can decide the quadrant, whether it is first quadrant, second, third, or the fourth quadrant. Okay. So can you tell me what is the quadrant of the resultant? So summation Fx is positive 22.3. So this is the direction of summation Fx. Summation Fy is 131.53. Direction is downward. So this is your summation Fy. So resultant, it will lie in the fourth quadrant. So this is the resultant. So basically, what is meaning of summation Fx and summation Fy? These are the X components and the Y components for the resultant. Okay. So we can represent this summation Fx is nothing but the Rx, that is the X component of resultant. So this is the Rx, and summation Fy, it is called as Y component of resultant, that is a Ry. So right now we have to find out this angle, that is theta, and the magnitude of the resultant. Okay. So we will use the resultant formula. R is equal to, so this is the fourth step. R is equal to, it is square root summation fx square plus summation fy square. So that is equal to 22.3 square plus 131.53. So we will get the resultant value R is equal to, it is 133.4. So this is the value of resultant. Okay. And now we have to find out the angle. So angle is theta, that is equal to tan inverse summation fy divided by summation fx. So this is equal to, it is tan inverse. Only consider the positive value because we know the quadrant. Okay. So to find out theta, just put the value positive 131, that is summation fy, and 22.3. So we will get the angle as 80.37. Okay, so this angle, when we take summation fy in the numerator, it will be always with respect to x-axis. So this is the angle theta. Okay, so your resultant R is equal to 133.42 kilonewton, and its direction, so this is the representation, so this is the theta. Okay, and this angle theta is equal to 130, sorry, it is 80.37 degree. So this is the complete representation for the resultant. Now next question is, we have to locate that resultant on the base AD. So you have to find out at which point this resultant will intersect the base AD. Okay. R is equal to 133.4 kilonewton. Theta is 80.37 degree. And resultant is in the fourth quadrant. Okay. So we will draw the resultant system. So on this structure, this is a base AD. Our resultant, it will lie in this direction. So this is the resultant. We know the angle with respect to x-axis. So this is equal to theta. Now we have to find out on this base AD. Let us consider this intersection as a point S. Okay. So we have to find out this distance AS. So to find out this distance, first we have to find out the perpendicular distance. So this is the perpendicular distance, that is a D. Okay. We can find out D by using Varignan's theorem. So what is Varignan's theorem? The summation of moment by all the forces in the system about any point, let us take this point A, is equal to the moment by the resultant about the same point A. So this is the Varignan's theorem. So to find out this summation of moment, we have to refer the system of forces, that is the original system consisting different forces, and to find out the right hand side, that is a moment by resultant, we have to refer this diagram. This is called as resultant force diagram. Okay, so just try to find out the left hand side first. So we have to refer the original diagram. So in this diagram, we have to take the summation of moment by all the forces about the point A. So just observe the first force, that is 50 kilonewton. So 50 kilonewton, it is at distance 2 meter with respect to point A. So what is the moment of this 50 kilonewton about point A? Just I will draw the separate figure. So this is the vertical wall. This is 50 kilonewton. And this is perpendicular. So this will be the perpendicular distance. And this is given as a 2 meter. Okay. And this is the point A. So moment by this 50 kilonewton about the point A, it will be in the clockwise direction, because this 50 kilonewton, it will try to rotate this system in the clockwise direction. So moment in the clockwise direction is negative. Okay. So this is the sign convention. If moment is clockwise, it is negative. If moment is anti-clockwise, it is positive. Okay. So we will write this moment. Force into perpendicular distance. So force is 50. Perpendicular distance is 2 meter. And it is clockwise. Therefore, it is minus. Consider second force. That is 120. So this 120, its perpendicular distance with respect to point A. So if I extend this line of action, so line of action means what? It is an imaginary line passing through the force. So this distance, it will be perpendicular distance. Okay. So it is given directly as a 2 meter. So force is 120, distance is 2 meter. So moment will be 120 into 2. Now we have to decide whether it is clockwise or anti-clockwise. Okay. So just consider. So this is the point A. This is the line of action for that force. This is the actual force 120. And this distance is nothing but the perpendicular distance. So that is equal to 2 meter. So when this force will pass through this line, it will try to rotate complete system in this direction. So this direction is clockwise about point A. So this moment is again minus 120 into 2. Okay. Now the last force is 30 kilonewton. So we have resolved this 30 kilonewton into X component and Y component. Okay. So do not consider this 30 kilonewton. Now just concentrate on these components, X component and the Y component. Okay. So just consider the X component. So for the X component, what will be the perpendicular distance? So I will draw this figure separately. So this is the inclined surface, that is the downstream side. This is the base AD. So this is point D. This is A. This is the vertical wall. And this is the X component. So this X component is 30 cos 22.62. Okay. To find out the perpendicular distance with respect to point A, just extend the line of action. Okay, and this distance, it will be a perpendicular distance. So what is meaning of perpendicular distance? That distance must be perpendicular to the line of action. Okay, so we have to find out this distance that is not available in this figure, but one distance is given. So this is the point M we have taken. So this inclined distance is given as a 1.5. Okay, we have this angle, so this is a phi. Okay, so we can find out this distance by considering this right angle triangle. Okay, so this distance, it is equal to 1.5. This is a diagonal in this right angle triangle. Okay, and this is the opposite side. So 1.5 sine angle is phi. Okay, so what is the phi? So I think it is 67. Just refer your previous calculation, 67.4. Okay, so the perpendicular side or perpendicular distance, it will be 1.5 sine 67.4, and that is equal to 1.38. So this is equal to 1.38. So now take the moment. Force is 30 cos 22.62. Into perpendicular distance is 1.38. Now we have to decide whether that moment is clockwise or anti-clockwise. Okay, so just observe this sense of rotation by this force about the point A. This is the line of action, so we can consider the force even at this location. It doesn't matter, because force magnitude on its line of action anywhere will remain same. So this is the force, so it will try to rotate the complete structure in the anti-clockwise direction, so it is positive. So this complete moment. Next, consider the 30 sine 22.62. Okay, so this is the point A, this is the point M, and this vertical force, it is 30 sine 22.62. So if I extend this line, that is will be line of action, this distance, it will be a perpendicular distance. Okay, let us take this point as a point K. This point is D. We know this value. This is 67.4. That is a phi. Okay. So for this perpendicular distance, we have to find out this small distance KD, and then we have to subtract this complete KD distance from 5 meter. Okay. So this will be 5 minus KD. So KD distance we can find out by using this trigonometry. So this is 1.5. So this is adjacent side. So KD, it is equal to 1.5 cos 67.4. 67.4 means what? It is a phi value. Okay. So AK distance is the perpendicular distance. So AK is equal to 5. This total distance AD is 5 minus this 1.5 cos 67.4. So this is equal to it is 4.42 meter. Okay. So take the moment by this 30 sine 22.62. So it is 30 sine 22.62 into its perpendicular distance is AK, that is equal to 4.42. Now just decide the direction of moment. So this force is acting at this point. So it will try to rotate the system in the clockwise direction about the point A. So complete moment will be negative. Okay, so this is complete summation of moment by all the forces about the point A. by 50, by 120, and by this 30 kilonewton. So calculate this complete value. So this complete value is minus 352.78 kilonewton meter, because unit for moment is Newton meter if the force is given in Newton, or if the force is given in kilonewton, it will be kilonewton meter. So this is the left hand side for the Varignan's theorem. Okay. Now just observe the right hand side. Moment by resultant about the point A. So I will write the value for left hand side. So this is minus 352.78. It is equal to moment by resultant. So observe this figure. So resultant R into, we have considered the perpendicular distance as a D. So right now we have considered the resultant, it is like acting in the right side of the point A. So it will try to rotate the system in the clockwise direction. So it will be a clockwise moment. So it is minus. Okay. So we know the value of resultant. So D distance, it is equal to minus 352.78 divided by minus, what is the resultant value? It is 133.4. So we will get the value as, so D distance is 2.64. This is meter. So this is not a final answer. It is just a perpendicular distance with respect to point A. Okay. So now we have to find out the intersection point on the base AD. So we have this distance B, we have the angle theta. Okay. So if this is theta, this will be theta. These are the alternate angles. Okay. So let us take this distance as a x, that is a required distance. Okay. And consider this right angle triangle. So take this point as a point M, take this point as a P. So in the triangle AMP, you can use the trigonometry and you can get the value of x. We know the D, we know the theta. So how to find out the x? X is the diagonal. Okay. So you can use sine theta. So opposite side divided by the diagonal. So just use sine theta. It is equal to, opposite side is distance D, diagonal is x. So x is equal to D divided by sine theta. So D distance is 2.64 and your theta value, it is 80.37. So you will get the value x is equal to, it is 2.68. So this is your final answer. The question was, we have to locate the resultant and we have to find out intersection of that resultant on the base AD for the given dam. So this is the base AD, point P is the intersection for the resultant, and x is the distance with respect to corner point. Okay, that is equal to 2.68. So I hope this complete problem is clear to you. So if you have any doubt, you can ask.